To begin with, I would like to talk about the specific real corrugation. Just as shown in the photograph and the detail mirrored, short picture corrugation have occurred clearly at sections in metal lengths where high inelastic real fasteners are used. The corresponding wavelength is in a range of 25 to 30 millimeters. 30 millimeters because its adverse influences, just as the vibration and the noise and the frequent real grading. It is essential to establish the formation cause of this specific corrugation. The next part, that is multiple wheel interaction. The fourth point is the modern slab track wheel system. In this system, the real fastener stiffness is only 10 kilonewton per millimeters. The rail, coupled with the four wheels, is represented by a finite inner balloon beam. The rolling contact between the wheel and the rail is treated as a nonlinear Hertz spring. On one hand, the active force can be calculated using a relative displacement excitation method. On the other hand, in time domain, the equation for the vertical vibration of the rail and for the wheels can be obtained by this, and the contact force in time series are solved using a model analysis method and the fourth order range quota method. Okay, the next point is the properties of the wheel-rail interaction force. It is worth noting that the contact force in time series for wheel 1 and 2 can be said to fluctuate periodically with a wavelength of 2.5 meters. 0.5 meters wavelength. 2.5 meters, and this wavelength is just equal to the shorter wheelbase, and at velocity 20 meters per second, the frequency is 8 Hertz. However, at this frequency, the active force spectra is smooth. There are two reasons for this phenomenon. The first, since the active and the passive force are all involved in time domain model, the standing wave is formed due to deformation wave interference between the wheels and the resonant track. The second, because the phase velocity of bending wave in the rail is much larger than the wheel speed, this type of standing wave occur periodically, so that large fluctuation of the interaction force are caused. Okay. The third point is rolling contact and the wheel. Here, the tangential contact between the wheel and the rail is modeled using the two-dimensional contact model. The wheel is only generated in the slip zone and assumed to be proportional to frictional work, and the local wheel and the corresponding wheel depths can be obtained by these two equations respectively. In addition, after each wheel passage, a new profile is formed and used as the roughness input to the subsequent wheel-rail interactions. Accordingly, the new profile of the rail can be calculated by this equation. Accordingly, Consequently, after after a large number of wheel passages, formation process of real corrugation are simulated. Okay, let's turn our attention to the fourth part, simulation results. The first point is the corrugation caused by wheel 1 and 2, respectively. It can be said the recorrugation with a wavelength of 25.6 millimeters grow most rapidly for wheel 1 and 2. Furthermore, the short wheel, at wheel speed 20 meters per second, the characteristic wavelength obtained is consistent with a high peak of the active force, not only, but also with a determined in situ. That indicates that the prediction on short pitch recorrugation of the active force is believable, although the passive force is ignored. Okay, the next point is a corrugation caused by multiple wheels. In practice, multiple wheels can produce wheel on the real head simultaneously. It can be said the standing wave shift corrugation profile with a 2.5 meters wavelength occur periodically, and this wavelength is still equal to the short wheelbase. And from the micro profile, it can be said short pitch recorrugation with a 25.6 millimeters grow together with a longer component, and the short wavelength component goes more quickly, and is in agreement with the results mirrored in situ. Just as mentioned in the second part, there are two reasons for this phenomenon. One is that the standing wave is formed between the wheels. Second, the phase velocity of bending wave in real is much larger than wheel speed. The standing wave occur periodically, so that the corrugation profile inherits the standing wave shape, and the additional uneven wheel are caused on real head, and thus the real corrugation. Okay, let's switch over to the third point, the corrugation caused by single wheel. We can say the standing wave shift corrugation profile with a 2.5 meters wavelength disappear due to the absence of this displacement wave interference from other wheels. Moreover, the short wheel pitch corrugation with a 25.6 millimeters scarcely grow. It further indicates that between the standing wave between the wheels led to the rapid growth of the real corrugation. Okay. This slide bring us to the end of my presentation. Okay, and the multiple variable interactions, the formation cause of a standing real corrugation at resonance track is investigated numerically by combining wheel dynamics, contact mechanics, and wheel. To sum up, I would like to leave you with the following conclusions. The first is a prediction on the short pitch corrugation of the active force based on the moving reference method is believable. Second is the standing wave between the wheels due to the standing wave caused by deformation wave interference between the wheels and the resonant track is responsible for the rapid growth of real corrugation. That's all. Thank you for your attention.
Thank you very much.